In this video, we use our linear equations to do some modeling. So this is an introduction to modeling. And here's some problems. It says, find an equation, y equals mx plus b, that models the quantity y after x units of time. And this one says the quantity y is initially 20 and increases at a rate of 4 per minute. So this initial quantity y, that's when no time has happened. So this is the initial time. So this is your y-intercept. So this is b. So b is 20. Because it tells us that it's increasing, then we know that our slope is going to be positive. And the rate tells us that that's slope, the word rate, 4 per minute. So we're going to write y equals 4x plus 20. And that's going to model this particular problem. Okay, look at the next one. It says a quantity y is initially 75 and decreases at a rate of 5 per second. So initially 75, that's your y-intercept. And decreases means you're going to have a negative slope. And the rate of 5, so a negative 5 for our slope. So y equals negative 5x plus 75 is a good model for this problem. Here it says, write an equation that models the described quantity. Specify what each variable represents. A tank contains 100 gallons of water and is being filled at a rate of 2 gallons per minute. So this is our B. This is the initial amount of water in the tank. And the rate is 2 gallons per minute. So that's our slope. So y equals 2x plus 100 is our equation. Now they did want us to define a variable. So here x is the time, how long you've been filling the water, right? It's in minutes. Minutes that you've been filling the tank. And your y is how many gallons are in the tank after x minutes. So that's the volume of water that's in the tank. All right, an athlete has run 8 miles and is jogging at 5 miles per hour. So we're assuming we're starting this after he's jogged his 8 miles. So b equals 8, and his slope is 5. That's his rate of change. So x is the number of hours he's been running. The athlete's been running, and then y is going to give us the miles he's run. So how many miles does he run? So then y equals 5x plus 8. And that's our model. The next equation says, the next problem says, a worker has already earned $110 and is paid $11 per hour. So x is the number of hours that the worker works after he's earned his $110, and y is his new pay, his pay. So 11x plus 110, because I'm sure you figured out which was the slope and which was the y-intercept for that. Okay, and here we have a picture. It says the data points are here on the right, and these are the y coordinates are in thousands, and this is the prison population based on a given year. So we're going to use the first and last data points to determine a line that models the data, and then we're going to write the equation in slope-intercept form. So let's look at just the first and last points. So remember, our x-coordinate is the year, and our y-coordinate is the amount of prisoners in the prison in thousands. So let's find the slope, and we're going to use our slope formula. As you recall, that is, you're going to subtract the y values, and then you're going to subtract the x values. And so here we get 176 minus 154, and so that's 24. And then 2005 minus 2002 is 3, and 24 divided by 3 is 8. So our slope is 8. And now we need to find our y-intercept. So we're going to use the techniques that we learned in previous videos We're going to write our formula as much as we have it. So that's y equals 8x plus b. And then you get to use one of your 2 points. And let's just use the first point. Substitute in for y and x and solve for b. So notice how the 152 got substituted for y. The 2002 substituted for x. And now we're just going to do a little bit of algebra here to get our b. So we'll subtract that 16,016 from the 152. And when we do that, we get b equals, let's see, b equals negative 15,864. So here's our new equation. Y equals 8x minus 15,864. That's part A. Part B says use the line to estimate the population in 2009. So we're going to let x be 2009, and we're going to substitute into the equation and then solve for y. And that'll give us our population in thousands for the year 2009. So it's a little bit of algebra going on here now. And after we subtract, we get y equals 208. And remember, this is 208,000 prisoners in the year 2009, according to our model.